Okay, everybody, I know we just did a video yesterday and I apologize for 2 in a row, but I want to get through just a little bit today. I promise the video will not be too long. We are on page, let's see, page 10 in your new note packet. Okay, I'll write that in the top. We are at page 10, and that's in part 3. Okay, so today is kind of an extension lesson. We are talking about parent functions and graphs in relation to those parent functions. So example 1, graphing linear functions and comparing a linear function to and I just said it to you, we're talking about parent functions. And when we're talking about the linear world, f of x equals x is my parent function. And I hope you guys know how to graph that, right? I'm just gonna do this real quick. You guys should be using your straight edges. There's my x-axis. There's my y-axis. Okay, and f of x equals x is like y equals x. So that graph is going to go through the origin. Okay, and it's going to look something like that, right? If we get our line and we connect it here. If I can get it to be straight here, it's something like that, okay? That is always going to be, when we're talking about linear equations, our parent function, okay? And we compare everything in relation to that. So if we go down, in the following graphs, note that the parent function is shown as the blue line, okay? And the slopes of the lines are the same. M equals, and that's going to be 1, okay? But the y-intercepts, that's the important part here, have changed. The new graph lines are considered part of the f of x equals x family, okay? So I'm going to be doing a lot of talking here. A lot of it's already written for you. If you see this right here, we have g of x equals x plus 3, okay? So this blue line right here is f of x equals x, which is our parent, okay? And you can see here that the only change we made was adding 3 at the end. And this is called a vertical translation, okay? A vertical translation, and it's up 3 units. We moved up 1, 2, 3. Each point went up, okay? In comparison, here on the second one, we have h of x equals x minus 4. So again, my blue line is my parent. The parent for linear equations is always f of x equals x. And then we went down, and we went down by 4 units. So we're going to say that this is a vertical translation again. But this time it's down, and it's down 4 units. Okay, so I hope you see that all we do is we take that f of x, that parent, and here we were either adding 3 or subtracting 4, and that moved it or shifted it up and down. Okay, moving on to page 11. Okay, we have another graph here, f of x equals 2x. Again, my blue is my parent, so I always like to label it f of x equals x. And that red line is graphed for you as 2x. And you can see that there was somewhat of a vertical, well, all these things are vertical. This one is a vertical stretch, okay? And you're gonna call it a scale factor. It's not a slope. Okay, it's a scale factor. We went up, we increased by 2. Okay, so a scale factor of 2, and remember, this is not a slope, okay? And a lot of times when you hear me say scale factor, I'm gonna say a k value of 2. That's the same as a scale factor. Okay, and I want to make sure you always know that it's also the absolute value. So if you had f of x equals negative 2x, it would still be a scale factor of 2, okay? Because we take the absolute value of that. And then if we look over at 1D, let's see, my blue is my f of x, my parent. And here we have a vertical. It's not a stretch this time, okay? It's called a shrink. And that's because your value is between negative 1 and 1. It's a fraction, okay? With a scale factor or a k value of 1/2. So you can also say just k equals 1/2. Okay, and if we're thinking about what's considered a stretch and what's considered a shrink, if you are in this territory, so negative 1 on down or 1 on up, okay, we'll color that. And that right there, that is a stretch. and that is a stretch. Okay, but let's switch colors here. If we are in between, if we're right here, so 1/2, 1/3, 3/4, we are a shrink, okay? So that's why 2 is a stretch, -2 would be a stretch, 5 would be a stretch, but 1/2 was a shrink, okay? Moving right along, if we turn to the next page, one other thing we have to keep in mind is when we have a negative slope, okay? So here we have, again, I'm going to write this in, we have our parent, which is f of x equals x, okay? And then here you can see that there was a reflection, right? There was a reflection in the x-axis, okay? And basically what you look at for that, if there's a reflection, let's move this a little bit here. Okay, we're kind of thinking of it as the slope, okay? Any number that is negative is always a reflection in the x-axis, okay? Now keep in mind, you can also have a stretch or a shrink along with that. So if you look up at this problem, at -x, there was no stretch or shrink. But let's look at the one next door, and I think you'll see the difference. P of x equals -3x, okay? So again, I just label my parent, f of x equals x. And I hope you see that this is, again, there's that negative. So if it's a negative slope, it's a reflection. Always a negative slope, it means a reflection in the x-axis. Okay, but that's not all there is. There's that 3 attached to the x. So that means that we also have a vertical stretch by a scale factor or a k value, and it's always absolute value, it's positive, so my k value is 3, okay? Let's move along. We're actually close to being done. If you look at page 13, okay, I'm only going to briefly mention this. I just want to make sure you're crystal clear on this, especially when we get into it next semester. Example 2 is comparing a function to the, and I hope you remember this from one of our beginning videos in this unit, that this is a quadratic function, okay? And the parent, which is in blue, is f of x equals x squared. So the parent for a linear function is f of x equals x, and for a quadratic function, it's f of x equals x squared. Okay, and you can kind of see here what's going on. That blue is the parent, okay, and it's either being pulled, sorry, my marker wasn't on. It's either being pulled this way or kind of pushed outward, right? So when we look at this, the red parabola in the equation g of x equals, let me think about this for a second. I think that's wrong. This is actually, oh, cross that out. That's my typo, I apologize. That should be g of x equals 3x squared. Sorry about that. This is called a vertical stretch by a scale factor, of 3, okay? Or you can say k equals 3. So if we go back up and look at this, that red parabola, let's just look at it for a second. In the blue, it's being stretched, so it's kind of pulled up, right? On the other hand, the green parabola in the equation, and again, that's my same little typo here, I believe that is 1/3 x squared just by looking at it. And this is called a vertical shrink with a scale factor of 1/3. Or you can say a k value of 1/3, okay? So that's kind of how we determine a graph's movement based on that parent function. Okay, I'm gonna skip around a little bit and I want you to flip to page 18, okay? So if we go down and you can look at page 14 as a review. That's a nice one. We're gonna skip this for now and we are gonna go down to page 18. It says graph the function g of x equals x plus 9 and complete the table below. Okay, so I always graph the parent function and I graph the equation they give me here, which is x plus 9. Okay, so if I get a line here, I'm going to graph my x and y axis. Okay, there's my x. Well, that's not very pretty, but you guys get the idea. So there is my x, and there's my y, okay? If we are graphing our parent function, which I always do first, f of x equals x, we're just graphing it like this, right? It goes right through that origin. Okay, I'm going to connect my lines. And you guys get the idea here, and I would absolutely label it. Okay, there's your parent. Okay, and then we have g of x equals x plus 9. I hope that you recognize what that's going to give you. So let's see. We have g of x equals x plus 9. Okay, now when we're talking about this new function here, you recognize that the y-intercept is 0, 9. Okay, and my x-intercept, that's if we plug 0 in for y, so we're going to have 0 equals, what, x plus 9? We're going to get x equals negative 9. So we have negative 9, 0. So we go from our parent of 0, 0 to 0, 9, and our parent of 0, 0 to negative 9, 0. Okay, and just by looking at the equation, you should notice that there's no number attached to that x. So we do not, let's see, do we have a vertical stretch or none? We have none. There's not one. Okay, and a vertical translation or slide? Well, yes, we do. And we are going up by 9 units, okay? Is there a reflection? No, because we would need a negative slope for there to be a reflection, okay? I'm not going to do page 19, but just glance at it real quick. I hope you recognize on page 19 that we have h of x equals 5x. So that is going to be a vertical stretch by a k-factor of 5. Okay, and there is no translation and there is no reflection. Okay, but I want to get to the last page in the notes, which is page 21, because this is a little more interesting, I think. And let's go down here. We're going to skip this and we're going to go to page 21. This is kind of a comprehensive list of stretches, shrinks, and reflections. So here's our parent right there. And then we have some examples here to tell us what we're doing. Don't worry so much. You can't tell what the x-intercepts are by looking. You can tell what your y-intercepts are. So we go from a parent, which is 0, 0, to 0, negative 7. Here we go 0, 0 to 0, 4. Sorry, that should be a little arrow. And here we start with our parent, which is 0, 0, and we go to 0, negative 2.5. Okay? Then we look to see if there's a stretch or a shrink. Okay? On this one right here, you can see the number attached to the x is 12. So yes, we do have, in this case, we have a vertical stretch. And the scale factor is k equals 12. Okay? On this guy right here, well, yes, again, this time we have a shrink, right? Because we have that fraction. And the scale factor, make sure it's always an absolute value. So even though it says a negative 2/3, the scale factor is only, oopsie, I just said it and then I did it. Our scale factor is a positive 2/3, okay? In this last one, we have a vertical stretch by a scale factor of 2. Okay, then I go down to my translations. And in this one, we do have a translation, right? We have a translation. It's going down, and it's going down 7 units. This one, yes, we're going up 4 units. And on this last one, we have a translation. It is going down because it's negative by 2.5 units. Okay, and then my last thing I look at is that reflection in the x-axis, and I'm just looking for a negative slope. So the only one that has a negative slope is g of x. So when I go down here, I'm going to say this one does not, This one does, and this one does not. Okay, and that's kind of a comprehensive list of how you can tell whether there's a vertical stretch, a vertical translation, and a reflection in the x-axis.